All right, let's do some math. So here we have 3x equals 6, and we have our representational connection here, showing our 3x's equivalent to our 6 units. And our goal here throughout this entire progression is to show the connection of using division and proportional reasoning to find your quotient. So with my representation, I can see, hey, I have these 6 units that I need to equally share to each x value, because my goal when solving an equation is to find the value of the unknown variable. One of the ways we can do this is by isolating our variable. And so understanding that I need to divide both sides into 3 groups. So I see that 6 divided by 3 can be simplified to 2 over 1. So my value of x is equal to 2, because 2 is the value that makes that equation true. And so now we come over here, and now we have 4x is equal to 22. And right off the bat, I see that 22 is not divisible by 4 to give you a whole number quotient. And so I know, though, from my representation, I'm going to take all of these units and I'm going to share them equally into my 4 x's, which means I'm using division to isolate that x. So again, 22 divided by 4, they are both even, so I see I can simplify this expression by 2 to get 11 divided by 2, which I can divide by 2 again, and I get 5 5/10 over 1. So my value of x is equal to 5 5/10. Now we're moving from our progression with our algebra tile representations into a rational model. And so we have our fraction circle with only 1/3 of the circle being shaded, because I only have 1/3 of my unknown value. And I know that that's equal to 4 units. And so again, I need to divide 4 into the 1/3 of the value that I was given. So I'm going to divide both sides by 1/3, which I can express in my ratio table. 4 divided into the 1/3, well, I don't want just 1/3 of this x value. I want the whole unknown. So what I can actually do is I can scale up, and 3 groups of 1/3 gives me 1 whole value of x, and 3 groups of 4 gives me 12. So my unknown value of x is equal to 12, which if we connect back to our model, is easy to see, because if each 1/3 of the x is 4, it takes 3 groups of the 4 to make the whole x. So now we have a coefficient that is not a unit fraction, meaning my numerator is not 1. So I have my model with my 2/3 of the unknown value of x, and that it's equal to 10 units. So again, like this entire progression, I know I need to divide my units into 2/3 of a group. So I'm going to express that as my ratio table. Although here, I'm not quite sure, I can't just scale up to 1 whole. So what I'm going to do is I'm going to scale down, very similar to our previous problem, and I'm going to find what 1/3 of my unknown x is, which means I'm going to divide by 2. So now I know that 5 is equivalent to 1/3 of my group, which if we were using our representation tells me I can take these 5 units and share it with this 1/3 of x, and these 5 units and share it with this 1/3 of x, meaning 1/3 of my unknown value is equal to 5. And now I know my unit value, I can scale back up to find that 1 whole value of x is equal to 15. So x will equal 15 here. And then lastly, now we have 2 5/10 of x is equal to 8. Modeled with our fraction circles, because 5/10 is equivalent to our 1/2. And all of this is equal to our 8 units. So again, I'm sharing these 8 units equally into 2.5 groups, meaning I will be dividing. And I can represent this in my ratio table. So 8 divided into 2 5/10 of a group. Instead of scaling down to scale up now, I actually see, hey, I can double 2 5/10 to make 5. So I'm going to scale up. So 16 divided by 5 is the same as 8 divided by 2.5. And I see I can scale up one more time to make 10. So now I have 160, oh, excuse me, 32 divided by 10. So I've scaled all the way up to a friendly number, right? I have 32 divided by 10, and now I can divide back down by 10 to get 3.2. So my value of x will be 3.2.